Welcome to InnerAutomation. In this video, we'll guide you through how to calculate and choose the right shunt regeneration resistor for your servo or VFD system. You'll learn when it's needed, how to size it, and how to avoid common mistakes, all with real formulas and practical examples from industrial environments. When a motor decelerates, especially with high inertia or vertical loads, it acts as a generator. This feeds energy back to the DC bus, increasing voltage. If the drive can't absorb this energy internally, a shunt or dynamic braking resistor is used to safely dissipate the excess as heat. This protects both the drive and the power supply. Not every system needs a Regen resistor, but if you're dealing with a vertical axis like a Z drive, or if you brake frequently or quickly, then you almost certainly need one. Without it, your drive could trip or get damaged from DC bus overvoltage. Before sizing the resistor, gather some key parameters. You'll need the system inertia, the typical speed during deceleration, how quickly you need to brake, the DC bus voltage of the drive, and how often braking occurs, also called the duty cycle. The total energy to dissipate during braking is calculated as half the inertia times the square of the angular velocity. To find the required resistor power, divide that energy by the braking time. Finally, use Ohm's law to find a resistance value. Voltage squared divided by power. Let's run through a simple example. Say you have 0.05 kilogram to squared meter of load inertia rotating at 1500 RPM. That's about 157 radians per second. You want to stop in 1 second. Plugging into the formulas. The braking power is 615 watts. With a 600-volt bus, that leads to a resistor value of about 585 ohms. Now that you've calculated the required power and resistance, pick a resistor with a voltage rating higher than your DC bus, a power rating that matches or exceeds peak and average braking power, and is thermally rated for your duty cycle. Don't forget, cooling and proper mounting are essential. Here are some common mistakes. Using a resistor with a voltage rating too close to the DC bus, ignoring peak power, mounting the resistor in a confined space with no airflow, or forgetting to enable the braking function in the drive configuration. Any of these can cause faults or hardware damage. Thanks for watching. If you found this helpful, make sure to follow InnerAutomation for more practical videos like this one, designed for engineers who build and tune real systems.